Hello, friends. Happy to have you here with me today. So, having some fun in Introduction to Java Programming by Daniel Liang, working in Chapter 18, the chapter on recursion. And a lot of the exercises that I'm working on are simple mathematical exercises where we've got an algorithm or we've got an equation, and we're saying, okay, this is the equation. Now, go find a recursive definition for this equation. And this is a lot of fun. This is something that's very useful. Sometimes it's easier to write a recursive definition than it is another one. And it just lets us see kind of some of the utility of the recursion. But it uses simple enough things that if we had to, often what we can do is do it a different way. That way we've got a way that we can verify and validate our answers. So that's what I want to share with you today. The problem we're going to work through today is the summation of a series. And so it says, write a recursive method to compute the following series. So let's go ahead, let's fire up Eclipse, and let's go ahead and see what we can get going with this, because I think it's going to be a good time. Okay, so let's go ahead and let's make a new package, and I'll call this Chapter 18 Exercise 05, and then I'll make a new class inside that, and I'll call it Chapter 18 Exercise 05. And we'll include the public static void main so that we can make sure that we get this done. Okay, a few housekeeping things as always. Make sure it starts. And as I have experienced a few times with these recursive calls, you also want to make sure that the sucker does finally come to an end and terminate. So now we've got that. Let's go ahead. Let's try to paste in our problem description. And so it says, sum a series. Screwed that up just a little bit. Let's do this, and then let's do this. There you go. M equals, and then our first term is a third plus, I believe it's 2/5. Yep, 2/5 plus 3 divided by 7 plus, I think it's 4 divided by 3, 5, 7, 9 plus, was 4/9 correct? Yep, 4/9 was correct. And now we do 5/11 and 6/13. And is it plus all the way? It's always plus. Good, good, good. Okay, and 6/13 plus, and the equation is I divided by 2 plus I, right? Make sure that is right. Yeah, I over 2 plus I. Now, let's go here, let's get rid of all this stuff. And it says, write a test program that displays it for the first 10 terms. Okay, so let's do int number of terms equals 1. Okay, and then let's do series sum number of terms. Okay, so that doesn't exist yet, so we'll go ahead and create it. And so now we'll come in here and we'll say sum equals 0. And then we'll say for int index equals 1, index less than or equal to number of terms, index plus plus. Now we'll say sum equals sum plus. It's going to be index we'll recast that as a double and divide that by 2.0 plus. There, grab that. And then drop in the semicolon. Oh. There we go. And then modify this just a little bit, make it a printf, and I say for, let's do %d terms, sum %f period, and return, and we will call that number of terms and sum. Save that, run that. Hey, I can live with that because I remember looking at the problem, and if we have one term, we get 1/3. All right, so I'm going to grab that because I like that. Paste that here down at the bottom just kind of as a comment. Now, two terms, let's get some expectations right quick. So two terms is going to be, it's going to be 1 divided by 3 plus 2 divided by fifths. This is equivalent to 0.33 plus 0.25, which is approximately 0.58, somewhere in that ballpark. So let's pop up here. Let's say number of terms equals 2. Run that. 2/5 is not 0.25. You gotta watch me sometimes, folks. I do crazy stuff. So 2/5 is going to be about 0.4. So shouldn't that be 7/8? So 2/5, 7/8. But 7/8 is not quite 0.8833. So let's do this. Let's come in here and let's slow this down a little bit. Let's do double new term equals 0. And so we'll come down here, new term equals, and that will just be this little part right here. That way we can then come back and we can say okay, index, so new term, all right, cool. Let's keep pulling this apart. Double new numerator and so now our new numerator equals index. And then our new, Let's recast this though as a double. There we go. And then new denominator is equal to cast that as a double, and that is going to be 2.0 plus, and you know what, it really should be this whole little thing right here. So I'll just paste that in right there. All right, and now we get new, and maybe typing's not my thing today. Divided by okay. And I probably need a semicolon right there because we're still in Java. Okay. 2/5 is still not 0.5, my friends. So index, you know what? Let's take that off right there. And let's let's take a look at that problem description right quick. So it is 2 times I plus 1. So that needs to be 2 times index plus 1.0. Okay, now give that a shot. Now, hey, you know what? That is what we needed. Okay, and so I got my equation wrong. That's why we do these things though. Okay, 2 terms. And so now let's just come back here and let's do 4 int number of terms equals 1. Number of terms less than or equal to 12. Why not? Let's get greedy. And number of terms plus, index that. There you go. There. A to select all, I to indent, and control F11 to run it. And there we go. So let's drop that in as a block comment. And so put that there. Okay, so I'm going to do just one more quick, not that I'm anything great at math, but 3 terms. It's going to be 1/3, 1/3, 2/5, and then 3/7. And that is equal to, let's go find out what 3/7 is right quick. It's going to be a little more than a half. So 3 divided by 7 is going to be something like 0.43. So let's just pop that in as 0.43. All right. So 3, 3, and 4, 3. The 3's on the end become 6. Don't have anything to carry. A 4 and a 4 is an 8 plus a 3 is 11, so 1.16-ish. Yeah, that's close enough. So I'm okay with this. I feel like I can trust that we've now got an equation that's doing the right thing. So let's look at the pattern right quick. So in my mind, and actually in my reality, I just got done redoing this. And this was that one that is exercise 4. And basically what we did recursively was we said, let's start at the last one, and then we'll calculate this term, and then we'll add it to the previous term. We'll keep adding it to the previous terms until we actually add it to 0. So I think we can do a similar thing here. So let's come in and let's say, all right, we'll do double our sum equals 0. And then we'll come in here and we'll say our sum equals some number of terms. Now, I want to make life simple for myself because I'm lazy. And so let's go ahead and create this. And so let's go through and let's start poking through this. So let's start out and say if 0 is the same thing as number of terms, and well, I'm going to actually return 0. That's perfect. Else, return, it's going to be double, and this is going to be number of terms. So let's just do this. Double number of terms, so that's my numerator, divided by double, and this is going to be 2 times number of terms plus 1. So that's actually recasting this as a double. So this whole thing, and then a semicolon. Yeah. Well, up here, need a semicolon, and then let's just grab our little, copy that, come up here, paste that here, and then cursive, just grab that, paste that over here. Yeah, whoop, yeah, maybe. I don't know, let's give it a shot, see what blows up. Cool, well that was not exciting. Nice and slow, try 2. Okay, see, that's a problem. That is not the number that we were looking to get. So that means somewhere I screwed up, right? So when, I'm pretty sure that I'm the one that screwed up on this one. So do stupid stuff first that really shouldn't have caused a problem. And we try it. Not so much. So let's see. We can grab these little things because and actually we can at the same time, because we're not looping these things, that's where I went wrong. I'm going to back all this out. plus, that's where I went wrong. I forgot minus 1. Okay, now let's try that. Yeah, so it turns out I was actually closer than I thought. So now that is getting our right thing. I just forgot that you not only have to add the new term, but then you tell it, okay, add the new term and everything else that's left until you get to the very end. All right, let's just get greedy because it doesn't cost much to get greedy. And we can see everything's lining up nicely. So cool. The little block that we're using that works really well, seems to work really well, is this little thing right here. Now, what's the difference between, oh, you know what? Let me go ahead and grab this. That way you've got the output as a comment. What's the difference between having this equation, which is inside a for loop, and having this equation, which is inside a recursive? Now, no, it's not to get rid of this stuff. I did that stuff because I can't math sometimes, and I'll admit that. The reason is sometimes it's actually easier to calculate a recursive definition than it is to calculate a traditional definition. And there are other applications of recursive algorithms that pop up. But anyway, it's a lot of fun. And I hope you enjoyed it. And I hope you continue to poke around with it and have some fun with it. So with that, I thank you all for your time. And I hope you have a wonderful day. Here's to happy programming.